Hi, welcome back to part 3 of the Illustrator exercise video series. In this video we're going to look at page 3, and with page 3 we step away from the idea of straight copying something that exists, and we're going to construct something from scratch that exists. We're going to take our own measurements and build a typical section of an existing street. Start by picking a street that you have access to, the street you live on, the street you work on, the street you pass every day. It's nice to be able to go out there and take your own picture, which, by the way, the picture is the least important thing on this, and a typical section typically doesn't even have a picture. It's just icing. But also you can confirm measurements if necessary, or just go out there and experience it in a different way and start to put together how the dimensions that we're using translate into pedestrian feel. All right, so we'll pick a street. I'll pick the street I live on. I live on Damon. And step 1 is to find some key measurements about that street. The key metric when we talk about streets is the right-of-way width. And to find the right-of-way width in Chicago, we're going to go to the Maps and Plats kiosk. This has changed since the last time I was here. But this is where we can find information on the right-of-way width. The right-of-way is the public way. It's what I don't own on my side of the street, you don't own on your side of the street, but it's what the public owns as a whole. So this is map widget shows some what they call 80-acre maps, and it looks like maybe I need to have map layers on. That's where it is, not the locate and search, but in the 80-acre map layers. Okay. All right, so this is the old hand-drawn Chicago maps of ownership, and they give you a lot of good information, and this changes, so by the time you're watching this video, this website might not look the same way it does. It's a bit of a moving target when we're looking for data because it's always changing. So you can see we've got street names, we've got lot numbers or parcel numbers. We've got lot widths. You see this 25 foot, and then the same, 25 by 120. That's a pretty typical Chicago lot dimension, or 25 by 125. You can see these down on the other side of the division are 24.2 or 24 by 121.45. But somewhere in that ballpark is your typical Chicago lot, something along those lines. 25 by 120, 25 by 125, something in that range. Also, what we're seeing here is the right-of-way width, and you have to sort of hunt for it and to find it. So it's actually these numbers, and it's a little fugitive on the screen. You see this 50, excuse me, and 50. That's 2/2 of the right-of-way. That's telling me that the Division Street right-of-way is 100 feet wide. That's quite a wide right-of-way for the city of Chicago. And actually, sort of as a side note, Division, I think, was originally supposed to be a boulevard, part of the boulevard system, and that's why it's so wide. If you go down there and hit any of the bars, not like you'd ever do that, you see that the sidewalks are all incredibly wide, and they have sidewalk seating easily on Division because the sidewalks are massive compared to other parts of the city. 100-foot right-of-way. I'm doing Damon, though, my street, and here it's numbers that don't mean anything else. 1200, that's 1200 north. 2000, that's 2000 west. That's the intersection of 1200 north, 2000 west. And here, these 33s, that's my half right-of-way on Damon. So Damon is 66-foot right-of-way. I don't know if you remember back to the first lecture where I was showing you some work I did for Metropolitan Planning Council, where I was studying right-of-way widths for BRTs. You'll find that you see the same numbers again and again for right-of-way widths. 66 is very common, 100 is very common, 80 is very common. Check out the alleys here. Typical Chicago alleys, 16 feet or 15 feet. You'll see a lot. Some smaller, but usually it's 15 or 16 feet. That's not a lot of space. If we look at this side street, Crystal, that's a 66-foot right-of-way. That's the same right-of-way width as Damon, formerly known as Roby Street. Okay, so that's the number I'm interested in, 66 feet. That's going to be the basis of how I'm going to do my construction in Illustrator. So these maps are actually really interesting, and they give you a lot more information than just the right-of-way width, obviously. All right, I opened up Illustrator. You'll recognize these old sheets from the previous videos. And here's my third sheet where I'm going to lay out this typical section. Okay, we're going to use Illustrator in a little different way this time. Notice that I've just been drawing stuff, and you don't see anything about scale. You don't see anything about measurements. It's just been illustrations. If we look, however, at the typical section, we see we're going to actually have dimensions. Notice here what I did as a student when I did this study as a MUP. I was looking at Michigan Avenue, and notice the odd number rights of way, 141. Very uncommon to have, is that even a prime number? Very uncommon to have a right of way of 141 or 116, actually a little odd too. Also, I want to emphasize again, the picture is the least important thing on here. These work without the picture. The picture is just icing on the cake. It's just a little decorative element. On a street like this, like Michigan Avenue, I feel that it would be incomplete if we didn't see that it was a canyon of high-rises. So I think it adds something. But typically you won't see any picture background. And why is that? Because it's somewhat misleading, because it's in perspective. And a typical section is not in perspective. It's flat. And anytime you see dimensions on a drawing, you know that it's not in perspective. Because what do we know to be true about perspective? Things appear smaller as they move into the distance. So if I'm saying something is 141 feet wide, well, that exists at only one point in the picture, in the depth of field. As you go into the distance, you can see it appears to get smaller. As you come forward, it appears to get larger, right? That's what perspective is. So I'm sort of taking some liberties and mixing and matching things here. When in doubt, don't use a picture. It can only get you in trouble, and it's not needed. But I think in some cases, especially on a busy street like this, it's a nice touch. Just sort of dresses it up a little. But again, it's the least important thing on here. Okay, so you'll see dimensions on this, but you don't see a scale. This drawing is not what we call to scale. I can't tell you that you can pick up a architect's or engineer's scale, lay it on here, and say, I want to measure where the planter to the curb is. It's not to scale. You can't do that. But what it is proportionately accurate. That is to say, the length and width makes sense. So this is actually started out being drawn to scale, and then I resized it for this page. And if you think about scale, the idea of scale, at first it can be a little confusing if you don't work with it a lot, and I'm guessing that many of you don't. You know about map scale, and you understand probably the concept of scale. You've seen some architectural drawings or civil drawings. Map scales are typically expressed as a ratio, 1 to something, usually in the thousands. Architectural drawings are typically expressed in terms of a fraction of an inch equals a foot. It'll usually be like, it'll say scale 1/8 of an inch equals 1 foot 0 inches. It's a typical architectural scale. And civil scales, which is what planners usually use, are usually expressed in terms of 1 inch equals a number of feet. So 1 inch equals 50 feet, 1 inch equals 100 feet. Those are typical scales that planners and civil engineers use. And what that means is that for every inch on a printed drawing equals 100 feet or 50 feet in real life, right? And I emphasize that it's on a printed drawing because when we construct these things on the computer, if we're using AutoCAD or GIS, which are typically the tools that we would use to create drawings like that, we draw in what they call full size. I'm not thinking in terms of scale when I'm constructing something on the computer, excuse me, like in SketchUp or something. I draw it full size. And I only am concerned about scale when I have to decide how big of a sheet of paper I want to put it on. So in this drawing, which is not to scale, but it does hold scale. It could be a scale like 1 inch equals, you know, some fractional number, which you would never express because it's useless to a person who might want to measure something. But when I say it holds scale, it started off to scale and then I just shrunk it down proportionately so that the length and width still makes sense. So it's proportionate and it's held scale, but it's not drawn to a measurable scale that you could lay a scale on and measure it. When I say lay a scale on it, I'm talking about the plastic thing that you might call a ruler. That's properly called a scale. You can't lay a scale on this and measure something because it's not to scale. If you absolutely needed to measure something on here, what you could do is take a piece of paper. You know this is 16 feet. You mark off this interval of 16 feet, and you would hold this at an angle. It's hard to explain this without demonstrating it, but knowing that this is 16 feet, I could create something out of paper that would essentially like reverse engineer the scale of this. Anyway, enough said. So when I'm drawing this, I'm drawing it to scale. But when I'm printing this and putting this on a paper, it's not to scale because my priority isn't that it's to scale. My priority is that it fits on a sheet of paper, right? And that's actually your priority when you draw things to scale also. Just that if you're doing something that needs to be to scale, like an actual professional site plan, you need to pick a scale that also fits on a sheet of paper, and that can be a challenge. Okay, so how are we going to draw stuff to scale? So this is quote unquote on the computer, but in Illustrator we can't draw things full size because this represents the paper already in a way that GIS and AutoCAD and SketchUp does not. We have to start thinking in terms of scale right from the start. And the best way to think about drawing something to scale is to imagine that you're drawing it on grid paper. And Illustrator, you may have been seeing a grid on your screen all the time. I turn it off because I don't typically use it. But when I'm going to try and draw something to scale, I need to see it. So the scale is a toggle on or off, and you can find it on the view pull down. And because it's a toggle, I only have options to show or hide it. So now it's hidden, so my only option is to show grid, and that turns the grid on. Once it's on, my only option is to hide the grid. And if you can remember one more shortcut, it's control quotes. Control quotes toggles the grid on and off, if you've got room in your head for one more Adobe shortcut. Okay, so this is a 1-inch grid, and maybe you can see where this is going already. If I say 1 inch equals something, I can draw to scale. If I say 1 inch equals 100 feet, well, this is saying that this is 100 feet, this interval from here to here. Right? I'm going to draw a 100-foot square, right? If I assume that the grid is 1 inch equals 100 feet. Our drawing, however, is much, much smaller than that. My right-of-way is 66 feet. So you see that's going to fit in the space just between the curb on this drawing. So I would never use 1 inch. I would never use 1 inch equals 100 feet. To draw something that small. So what I'm going to do is draw this to scale, but then when I'm done drawing it, I'm going to shrink it or enlarge it, scale it down or scale it up so it fits on the page. And it's not going to be quote unquote to scale, but it will hold scale. So how am I going to draw this to scale? If we look at this grid, we can see that it's a 1 inch square, and its subdivisions are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 subdivisions to an inch. That is really useful because I can draw this at a scale of 1 inch equals 10 feet. That means each little square is 1 foot. That means if I need 66 feet, I know it's going to be 10, 20, 30, 40, 50, 60, and then 1, 2, 3, 4, 5, 6, or 6.6 inches long. For foreign students, you'll recognize this as the metric system, right? Very easy. It's much easier than the English system. Your grid, however, right now almost certainly is not at 1 inch equals 10. Your grid probably has 8 subdivisions. So what you want to do is change that to 10. And let's see, that's going to be under preferences, pull down edit, preferences, guides and grid. And here you can change the grid settings. So you can see where yours says 8, mine says 10. If for some reason we wanted a bigger grid than 1 inch, that's the major grid and the subdivision is the minor grid, we could change that here as well. But 1 inch grid is pretty useful for the way we usually work in Illustrator. So change your subdivisions to 10, and that way it'll be very easy to lay something out the right length. So the first thing that we start with is a center line. I'm going to make some new layers, and let's see how many layers do we actually need to create this drawing. Well, I need a center line, I need a right-of-way line, I'm going to need dimensions, I'm going to have some cars and some trees and people. Let's bust out a few more layers here. In fact, I'm going to make one called guidelines. And then I'm going to make one called PL for property line dash CL for center line. I'm going to make one called PL dash right away. This layer convention is a holdover from AutoCAD, where we like to have modular layer names. So PL is, I can have all my PL layers together and I can see them at a glance that this is all my property stuff, property line information if I want to turn on or off. Guidelines we want at the top. I'm going to double click on that and turn off print. We don't want that to print. Notice that it goes into a italicized layer name because it's telling me that it's not going to print now. I'm going to make the center line, PL center line current, and using the pen tool I'm just going to hold shift, so I'm going perfectly vertical, and draw a line. Okay, I want this in the center of my page, so that means I want the X value to be 4.25, right? Because my page is 8.5 by 11. The Y value, I don't much care because that's up and down. I'm not sure how big this is going to be yet or anything else, but that's my center line. I said my right-of-way line, my right-of-way width is 66 feet. In 1 inch equals 10 feet, that's 6.6 inches. If I divide that in half, that's 3.3 inches. So I'm going to select my center line. I'm going to go Object, Transform, Move. And notice that here I can define a distance of precise moving, and I'm defining 3.3 inches. Positive is to the right, and instead of saying OK, I'm going to make a copy, and that copied that now a perfect 3.3 inches from where it was. I'm going to select that center line again and go to the Object, Transform, Move again. And this time I'm going to go negative 3.3 inches. And I've got my preview button toggled so I can see where it's putting it, and that looks about right. I don't even need to count the grid at this point because I know that that's right, and I'm going to make that a copy. I'm going to select my 2 lines that I just made and put them on the right-of-way layer and test it. And yep, they go off. That's right-of-way. Now, right-of-way and center line usually take a line type, and that helps us distinguish what they are. The center line has what we call a center line type. Right-of-way lines are often drawn thicker and in what we call a phantom line. That's a double dashed line. See, the center line is a single dashed line. And we know something about how to create complex line types already. We'll go to the, with the center line selected, we'll go to the stroke panel. So window, stroke. This has more options. And I want to make that a dashed line, yes. This time I'm going to have to key in a series of dashes and gaps to make it look like a center line. And what does a center line look like again? It's basically long, short, long, short, long, short. some people are actually I'm very picky about my dashes and gaps when I'm doing lines. It's actually something that I think a lot about. So let's try a longer dash of 20, a shorter gap of 4, a shorter gap of 4, and a shorter gap of 4. Okay, so 20, 4, 4, 4. How does that work? 20, 4, 4, 4, and it repeats. Dash of 20, gap of 4, dash of 4, gap of 4. And that pattern is going to repeat. That's not bad. I said it wants to be a little thinner. I'm going to make it quite a bit thinner. That's a proper center line. And this is part of the graphic communication. This is going to look very different from the right-of-way line. And people in the field know what this means. Everybody knows this is a center line. You probably know this is a center line. Like my dashes may be a little bit longer here. I'm going to go to 28. Just to get a little more length on them. Okay, now I'm going to select my right-of-way lines, and I'm going to have to do something similar. This time I need a double dash, though. So that means I need another 4 and another 4. Okay, so it's a dash of 28, a gap of 4, dash of 4, gap of 4, dash of 4, gap of 4. And that's about as complex as you can make a line type on Illustrator. That's not bad, and I can see at a glance these tell me different things. This is a center line, it's thin, it's got a center line type. This is a right-of-way line, it's much thicker, and it's typically uses a phantom line type. Okay, what might help me is if I had these lined up maybe to my grid. Right now they're lined up sort of in the middle of a square. It would be nice if these were sort of lined up on a grid. To do that, I have two options. I can select everything, and this is at 1, 2, 3, 4 inches. One thing I can do is just move this to an X value of 4, and now everything is nicely on a grid. Right? This way, if I need to if I need to quickly see how big something is, I can see it on the grid, because remember, every little square equals 1 foot. So that's pretty easy to draw. That's actually right there is the trick to this. The rest of this is just simple lines. So I'm going to draw this section of the street. Mine has a Michigan Avenue. I picked a challenging street, and also I was doing a study. My master's project was on something about Michigan Avenue, so I did sort of a complex street intentionally. Most streets will not have that, so keep it in mind how complicated you want to work. So that's where my right-of-way comes from. Where do these other numbers come from? Well, those we're going to get at from Google Earth. So we'll look at, remember, R is the shortcut to go into plan view. And those we can take measurements off Google Earth and just take an inverse off Google Earth. And I may need to close and reopen because my video driver is acting a little wonky. All right, so here's a slice of Damon. And what we're interested in is the street width. So the street width, the main thing that interests us is the curb to curb distance. So I'm just going to use the measurement tool and make sure your units are set to feet. And I'll get some idea of the width here. So I'm getting a reading of something on the order of 44 and change. That makes sense because bike paths aside, this is a 44 divided by 4 is 11 feet. That's a rational number for an automobile lane. The minimum size of that varies depending on where you are, but that's a rational number that I can live with. So I'm going to call that 44 curb to curb. And then I can see I can fine tune it a little bit, and maybe I'll research this online. It looks like I got about 8 feet for the parking lane, And this is what I might research online. How big, how wide is a bike lane? Or, you know what I'll do? I'll go out with a tape measure and just measure it. It's one thing to have the standard that the city is shooting for, and it's quite another to go measure the result. So I'm going to call that, let's say 6 feet, 8 and 6, 8 and 6 on the other side. That would leave me with, what, 16 feet for the travel lanes. Looks like it's a little more than that. Looks like more like 20 feet. So I'll build it from the center, 20 feet from the center. That's two 10-foot lanes. That's, I think Chicago standard is 10 feet these days. And then has to add up to 44. So if that's 20, and then I've got 2 times 5, 10 for the bike lanes. That leaves me with 7 feet for my parking lane. I would have guessed 8, but something like that. So I'm going to start from the center. I'm going to work with 10-foot travel lanes, 5-foot bike lanes, and the remainder is parking lane at like 7 feet. And I'm going to walk out of my front door with a tape measure and confirm this. Why not? It's fun, sort of. It's supposed to be fun. But that gives me the other numbers that I need to work with. So here's where I'll get into that guidelines layer. What did I say? 10-foot travel lanes. So I'll use the same command, object transform move, and this time what's 10 feet? It's 1. 1 inch equals 10 feet, right? We're going to copy, and then the same the other way, transform move, this time -1, and copy. And I'm not going to ever want to see these except maybe to create some, use for my dimensioning. So I want to make sure that's on my guidelines layer. Also, I don't think I want those to be dashed. Also, cyan is a good reference layer color. It's a typical no print layer color back from the old days when we used to use colored pencil. If you didn't want something to print, you had these light blue pencils, and the reason being was that a Xerox copier wouldn't see it. You could lay this down on a Xerox copier machine, and it would not see the photo blue, and it would not get copied. So we did a lot of markups, things that we didn't want to print in a light blue color. So cyan's a good color for that. So here's 10 foot and 10 foot. There's my travel lanes. And then I said, 5 feet for the bike lanes. So select this again, object transform move. So 5 feet at 1 inch equals 10 feet. That's ½ an inch, right? I'm going to copy that. Object transform move. This time it's a -½ an inch. And make sure you copy and don't say OK, otherwise it'll actually move it. So here's my travel lane, bike lane, bike lane. The only thing missing is my parking lane. And right now we're at 10, 20, 30. And we said 44 feet back to back, so that leaves 14. So that means for right now, until I confirm it, I'm going to go with 7 feet for a parking lane. And I'm going to confirm these in the field. So how big is 7 feet at 1 inch equals 10 feet? It's going to be -0.7. This is why the metric system is so great. This is why we should have converted to the metric system in the United States, but we were too lazy and stupid, kind of like with COVID. We're too dumb to actually get the job done. It's so much easier. And 1 inch equals 10 is basically working with the metric system. So it's confusing for like 30 seconds. Then you realize, oh my God, it's so much easier. Okay, so there's my parking lane. I'll do the same thing here. Object transform move, this time a +0.7. Make sure you're copying, otherwise it'll just move it. Oops, something went wrong. Object transform move, 0.7. And copy. And what's left? That will be my sidewalk. All right, so it's sidewalk, parking lane, bike lane, through lane, bike lane, parking lane, sidewalk. What's on the right-of-way? Typically a fence, because on this side of the right-of-way, on this side of the right-of-way, somebody owns that. In this space, we all own it. It's the public right-of-way. So I'm going to go outside and confirm these measurements. Okay, so I've confirmed my Google Earth measurements in the field, and actually they were pretty close. They're close enough. My parking lane is a long 7 feet, meaning 7 and a couple inches, not enough to fret over, and my bike lane is a small 5 feet. I'm measuring to the center of stripe. Those stripes are usually 6 inches. And close enough for what we're doing here for a schematic like this, absolutely. So I've also labeled, as you can see, my lanes, because I will go crazy if I'll do something wrong if I don't constantly remind myself of what's what here. All right, let's. So I've got all the guidelines I need to make this happen, or do I? Let's take a look at the sample that we're trying to draw and check. So I've got all my vertical guidelines drawn, including my center line and right away. Now I've got this horizontal, basically the ground. I have to draw in this ground shape. So maybe a couple of more guidelines will be in order. I think guidelines are an easy way to stay organized, especially when you're first learning a drafting program, and we're very much using this as a drafting program at this point. I'm going to try some of the snap behavior, which I don't tend to care for. I'm going to snap to grid and see if this helps me draw. So this should snap to an intersection of a grid only, and you can feel it, you know, that magnetic behavior it has, snapping to something, just like when you're moving. V to get my cursor back. I'm going to zoom in and see. This is what I don't like about it. I find that it never actually does it perfectly, and you know, it's showing that it's on the grid. It felt like it snapped to the grid, but I'm guessing if I check the y coordinates, well, it says it's on the grid. All right, I'm not going to fret that. I'm going to accept that as being on the grid, and I'm going to make that match my other guidelines. Oh, here's a trick. I want this to match my other guidelines. Right now it has a fill of cyan and an outline of nothing. Well, you know that means it's invisible when it's a line. So I can change. I know what the settings should be to match my other ones, but here's a quick way if you want to match the look of something else. Select the entity you want to change, and using the eyedropper tool, you can just pick over an entity that you want it to look like, and it should change its look to that entity. And that can save you some time if you've got a more complex look. It doesn't copy everything, but it copies the basics. All right, so let's say this is going to be my absolute bottom line, my my bottom flat line. What is this business above it? Well, you can see that this shape is meant to duplicate, let's look at the simpler one, the street curb and gutter look. Okay, obviously you know this is what a street looks like. Sidewalks are a little higher, then you go down into the street, there's a curb there, and then on the other side of the street the same thing. On my more complex one, I have a median and a planter, but let's look at the basics. I'm actually, this is more like the street I'm drawing, Damon. What is this actually, if we were to look at it? Here's an engineering cross-section of a typical street construction. And what you can see is in this engineering cross-section, a lot of stuff that's not visible to you when you're experiencing the street, although none of this should come as much of a surprise. So here in section is the curb and gutter on both sides of the street. And we've got a couple of layers going from top to bottom, a couple of layers of, we've got bituminous, that just means, that's the black tarry stuff. I mean, bituminous, what does it actually mean? I think it means made from coal. Bituminous concrete surface court, that's the asphalt. That's a sticky thing, petromat, that's what binds the two top courses together. And then we've got an actual proper binder course that has some dimension, 1 to 2 inches, and that's the thickness. And then we've got a bunch of a base course, which is gravel, and that's all a street is, really. Now, obviously, there's all sorts of utilities and sewers and stuff, and that are underground. That's not what this is about. This is instructions on how to build a new street. But focusing on the curb and gutter, the street itself is a function of the curb and gutter. So when you're building a street, the curb and gutter goes in first, classically, and then the street is made to meet them. And notice it's drawn here to show that it's crowned in the middle a little. This is the classic curb and gutter street cross section, and many streets adhere to this, though not all. Notice that if we take a closer look at a curb and gutter detail, we see there's quite a bit of thought that goes into this as well. Notice it slopes down, and this is the gutter. And what the gutter is meant to do is the street slopes to here, and this is meant to channel water. It's got a positive slope on it, and once the water gets to the gutter, it goes laterally in the gutter to a drainage structure, usually a catch basin or an inlet. And that's how the system is meant to work. So notice that if you look at, and take a close look next time you're crossing the street, this is curved, and you know, everything's very specified, it's reinforced, and everything's, you know, quite you know, engineered. When you watch them do this now, when you watch them install curb and gutter, they've got all kinds of cool machines that do this. It almost comes out like Play-Doh. It comes out formed like this, and I've seen machines that kind of follow a string. The surveyor will go and like stake where the curb and gutter is supposed to go, and then this machine comes in and just like spits this out like Play-Doh or pasta. It's very cool when you see this put in. For our purposes, though, what we're interested in is mainly to draw this schematic representation of this. You can see I've done it here. We just want to make sure we have the step drawn correctly. And the key dimensions to be aware of, and to some extent is the key dimensions to be aware of when you're considering this not in detail but in planning, is the overall width. So this is called B612. Here's the 6 inches from back of curb to face of curb, and then 12 inches from face of curb to gutter flag. 12-inch gutter flag. This is actually the gutter flag. So the 612, 6 plus 12 is 18. 18 is 18 inches. That's the total width of a B612 concrete curb and gutter. When you're talking about roadway widths, planners typically talk about the distance from face of curb on one side to face of curb on the other side. Not so all disciplines. Engineers tend to talk more in terms of back of curb to back of curb. It's not a big deal to make the conversion. You can see that I've got here a 24-foot roadway. I'm going to add 1.5, so that's 3, so that's 27 feet back to back. If I want the face-to-face, we know it's 612 curb and gutter, or we can assume that for our purposes. So if it's 27 feet back to back, it's 26 feet face-to-face, because we're just taking off half a foot and half a foot on either side. Excuse me. So these are real common measurements that will come up in planning. And if you think that roadways and automobile infrastructure is not important in planning, you are kidding yourself. Very much still with us. The automobile-less future is not yet here, and roadway is a part of it, so it pays to understand a certain amount of what it's about. And frankly, you just kind of learned pretty much all you need to know as a planner. When they're telling you the width, they're talking face-to-face and something about the construction. Mostly, you don't need to get into the engineering parts of it. I'm the planner at an engineering company, so all this stuff is force-fed to me whether I want it or not. So I'm held to, a lot of times when I'm doing layout, and so it can be a little constricting, I'm held to engineering precision for a lot of the stuff I do, unlike in many planning firms, in all other strict planning firms where things can be a little more, a little freer. My work tends to be quite technical, working with tight tolerances and stuff like that. Okay, so now that we know what that's, oh, and the 6 inches also, that's the height of the curb. So looking at our Illustrator, I have the absolute bottom, and then I'm going to find the absolute top. I'm just going to use Shift Alt. I don't really care what that distance is. We don't want to have to draw engineered stuff like this. So it's like 15 inches or 1.5 or whatever. That's not important. What's important for our purposes drawing a schematic is just that we get the step right? And so the key thing here is that this is 6 inches down from the rest of it. So to do a precision move, I'm going to use the same tool I've been doing, Object Transform Move. This time I'm going to move in the vertical direction, negative 0.05. Right? Because 0.1 is a foot. Half of 0.1 is 0.05. So that's actually a 6-inch drop. And I'm going to copy. And if we zoom in, we can see this takes up, I don't know if you can see my grid, it's kind of light, but this takes up half a square. That's a 6-inch drop. Okay, seems like kind of a fine point, but you know, it's important to sort of understand. And frankly, if you approximate this, that's not a big deal. But it's important, it's something that you should know about anyway. I'm going to lock that guideline layer, and I'm going to make a new layer now, and I'm just going to call this ground. And with this, I'm just going to draw the actual shape that I'm looking for here. So here's the step that I just drew. I'm just going to block this in without too much care of differentiating, for example, between sidewalk and where the curb starts and all that. This is typically how you see it. What's important here is the sharing of space, sharing of the right-of-way asset, right? That's the big thing now. We want to reduce this and increase this. That's the contemporary planning dogma, right? Less resources to traffic, which has typically had a monopoly on right-of-way resources, and more sources for pedestrians and bike infrastructure and you know, so-called complete streets. So I'm going to now turn off my snap to grid because I've drawn. I want to snap to my guidelines because I took the trouble to draw those. Use the pen tool again with my ground layer current. I'm going to draw in black so I don't go crazy, or maybe a dark gray. And this is my highest point, so I'm going to start at this intersection, and it's going to give me those intersections, right? So here's the sidewalk. At the end of the sidewalk, I'm going to go down that half foot. There's my curb step. I'm going to put a snap at the intersection there, and I'll show you why in a second. And back to the curb at this sidewalk. And there's my big 6-inch drop. Seems like a lot to do, to do over nothing. And I'm going to close this shape. Remember, when you see that little circle on your cursor, you know the shape is closed. Okay, and that's pretty much it. Let's give it a fill so you can see what's going on. The last thing I'm going to do is let's select it again. I'm going to use my direct select tool, go inside the geometry, and move that center point up a ½ inch. That's the true nature of the street, right? Remember I told you it was crowned, and you've experienced this. It's higher in the middle than it slopes to the curb. Well, it turns out the top of the crown in the center is equal to the top of the back of curb, at least in a certain type of classic curb and gutter construction. So you can infer this, the crown in the center of the street is 6 inches taller than the lower point, because we know the curb is 6 inches. All right, that's a pretty good, a lot of times you won't see that on planning sections. It might be a little overkill, but since I'm talking about it, it's certainly easy to do. If I turn off my guidelines, I can start to see how, yeah, I've got a nice looking section there. That little ½ inch, that reads at this scale. You can see that. That's defining the roadway, no question about it. Okay, so that is all the tough drawing that we have to do. Other things to do are lay out the dimensions, but that shouldn't be a problem. I think we know how to do that. This is just lines, and we know about this dot, this arrowhead, how to apply that. Wouldn't be the worst thing if these were labeled, you know, by function, through lane or whatever, but that's not necessary. This is just to give you the basics. You've seen probably by this point a lot of styles of typical section. Mine is a little sort of miscellaneous. I've got certain pieces of this style, certain pieces of that style. This, like I said, this was done when I was a MUP. I had to get a project done, so I just sort of did something actually really quick. Notice if you were going to nitpick this, there's lots of things you could find wrong about it. What jumps out at me, is my center lines are way too thick. Center lines should be, of course, thicker than the right-of-way line, as I took pains to mention. I corrected that when I drew this one. We're not going to waste our time trying to draw cars and people like this. These are assets that you find or even pay for once, and then you have them. I have no trouble paying for other people's work. In fact, I prefer it. So I've already found these online. I think they were all free. Keep in mind you need to have either vector artwork, which is what we create in Illustrator, or if you're going to use pictures, as I have here on the cars, they have to be pictures which support transparency. You don't want to have white rectangles on every piece of clip art that you put in, and that's what a JPEG does. You will never get that white rectangle off your JPEG. It's always there because that's how JPEGs work. They don't support transparency. So where do we find those people in foliage, which is the key thing that lets us know how big everything is here? Go to Blackboard, and in the class directory, Illustrator for Planners, you'll see these Illustrator Assets. And what you're going to want to do is download these two files and unzip them. Try and stay organized with your files. I've made a new subdirectory in my video project, and I made a subdirectory called Ready-Mades, and these are where I just added those two zip files. So these are real easy to manage. There's a directory inside of there. I'm just going to unzip these zip files by copying their contents to the root directory of Ready-Mades, and we'll take a look at what's in there. In GIS, you're encouraged to keep these zip files because they represent sort of a clean copy of your data. A lot of times I'll delete those because I've just unzipped them. I've got the content already. I'm not doing GIS. I'm not worried about, nothing much is going to happen. Let's look at the trees first. So I've got a bunch of PSD files. That's Photoshop files. It's our next app in the Adobe Creative Cloud suite that we're going to look at. And the great thing about Creative Cloud is all the apps, file type works in different apps. I shouldn't say works, but it's recognized. So we could just drop Photoshop files into an Illustrator drawing. Take care, because they get big, much bigger than Illustrator files typically. I've got this little JPEG, and you can see what this is. If I double click on that, that's actually sort of a reference guide. I may have paid for these at some point. Let's look at the people. The people I have, what do you know? This is a familiar format, AI format. That's our Illustrator format. Let's take a look at the JPEG, and this should be an indicator of what's in the file. And that's all you really need. You don't need to get too specific. Just indicate people, indicate foliage. In this case, you might say these are two different styles, and you'd be right. The trees are photorealistic, and the forms are schematic, so that represents a certain disconnect in style. Since the AI file will open right up, let's just double click on that, and let's see what we have in there, and we should have some people. And we will see that these are not pictures. There are no pixels. Nothing's pixelating because this is a Illustrator shape, and that's really useful to us. Let's see, who should we take? Let's go with the senior citizens, right? So I'm just going to do a Windows copy, Control C, and we can see that they can all they're all fully editable. They're Illustrator shapes. That's really useful to us. Locked layer, and thanks Illustrator, because I should have these on their own layer. And here we go. So how big are people? Well, they're not 2 feet. I'm going to straighten them out a little bit. They're kind of leaning. They're not 2 feet, and they're not 20 feet. I know that every square is a foot, so I would say people are basically somewhere between 4 and 6 feet. Somewhere in that range, right? These guys have a little perspective on them, which I don't care for, but I'm not going to quibble. When you see them in detail, they'll read okay. Right now, let's see, 1, 2, 3, 4, 5, 6. They're a little tall still. right? 1, 2, 3, 4, 5. Okay, that's human. So they're slightly tall people. Let's drop it down. I don't want them to be too small because I want to make sure they read. So that's a person somewhere in the ballpark, 5 feet, not more than 6 feet, unless you want them to look really tall. Sometimes you need to exaggerate the scale, but in this case, we're working at such a large scale, it's not going to be a problem. What's also not going to be a problem is I'm not going to need to, when I'm done with this, scale this up or down because it's fitting on my 8.5 by 11 sheet almost perfectly. It's because it's 66-foot right away. Let's look at those other tree images. Now, if I double click on here, it's going to launch Photoshop. Let's just try that. Let's see what happens. And here we go. Pretty nice looking tree. We can see we've got different layers going on here. Top layer, here's the layers in the bottom right. Top layer is my foliage. Then I've got this sort of like bare tree. Then I've got just the branches. So 3 distinct layers making up quite a nice complex image. And that was, I think, just the first one I happened to open. So that's going to work out nice. I can just drag and drop into Illustrator, and it's making that link. Now, how tall is a tree? That's a trickier question than how tall is a human. Trees can be quite tall. So we need to, I'm holding down Shift, of course, when I resize anything. Let's see, these actually are in the Parkway on Damon. I just had a tree put in by the city and it just got done dying. Well, I tend to, it's a question of how mature the tree is, what kind of tree it is it? So trees can be any size, right? You can have an oak tree that meets oak trees across the street in the center. It's that big, right? For our purposes, though, anything that accurate would be a problem. So I want this to be taller than the people, but not like commandingly so, right? And what if I stretch this? That's a bad habit to get into, but I can stretch this image a little bit and make it taller and not wider. And that's kind of where I'm going with this. And the parkways are quite narrow. I failed to measure the parkway, but on a lot of streets they're actually quite narrow. Be observant as you start to study planning. It's part of the difficulty of studying and talking about urban planning is that everybody thinks they already know what it is. You think you know what's on the street. You think you know how big stuff is. You kind of don't. Not in a way, in a real accurate way that is going to help you, move the ball forward when you're trying to, do stuff like this. You'd be surprised. There's a lot of surprises there. I was a little surprised at how narrow that park lane was at 7 feet. That would be considered substandard in many suburbs that I do work in. Oh, there's just a shadow, a black and white version. Oh, that's nice. Get some color in there. Yeah, there we go. These, I think I did pay for these at some point, or somebody I worked for paid for them. Where did I get those cars from? You're on your own for that. You're going to have to do a little web search. I'm not providing you with the cars, but know that what you're looking for. And look, if you have to splash out $5 to have a bunch of actual usable shapes, that's money well spent. But my street's looking pretty good. Last thing I want to bring in, the least important element, is that photograph. I think I've got that also in my image ref. And I went out and took a picture of the street, my neighborhood, and of course you wouldn't expect it to be. Shift Alt to scale from the center of an image. You wouldn't expect this to actually be the right size, would you? Nothing ever is. I'm going to move this layer to the bottom because I know it wants to be in back of all this. All that's really important when you're placing this is to make sure it's centered. It's never going to line up, and depending on how your picture looks, it might not even be usable. I probably should have sat down on that center line and got a real sort of a real low view. That might have been interesting, but I don't need a lot of this stuff. Yeah, I'm gonna try sitting down next time. Take it at a early or late hour so you're not getting run over by a garbage truck. If you could finish this class without getting run over by a garbage truck, that's the preferred option. Okay, so you can see the problem here is that nothing lines up. I'm getting my trees in about the right place, but everything else is going to be off. I expect that because it's not accurate. It's in perspective. There's no way it could ever line up. The best I can hope for is for it to line up in one place. So the first thing I'm going to do is with that layer current, I'm going to make a clipping mask frame. Just drawing a rectangle. I'm not going to bother to colorize it now. You've seen the clipping mask trick enough times. Selecting the two entities, and I'm making clipping masks. So at least I'm starting to see it only in the space where I might use it. Next, I'm going to go ahead and take the opacity way down. This is totally supplemental information to what I'm showing. I don't want this to catch your eye. I want the focus to be on the shapes that I've drawn. And now I can try and get that a little closer. Yeah, the more I think about it, the more I think that the picture is a mistake. Give it a try. It's useful to sort of see how it adds up, and it's a bit of a primitive check on your shape, but it's never going to. I think that's about there. I like that it tells you something of the character of the street, but it does tend to confuse the eye. Maybe I would try some things with this, not fight the perspective. That's looking a little better. And maybe now I'll enlarge my maybe that makes a little more sense. Yeah, if the picture's giving you too much trouble, just cut it. But I think it's a nice, I do think it has its place. It gives you a little supplement. The whole thing's off center. I'm going to do a Control A, select all. I should make sure that my all my layers are unlocked that I'm about to edit. I'm not going to do a Control A. Actually, that would select everything in the entire, would it? Yeah, it selects everything on every artboard. So I'm just going to do a window that selects everything here. And I'm going to look at the reference point is in the center, and I can give it an X value of the center of the page, and that would be 4.25, right? It's 8.5 by 11, and now we can see that it's in the perfect center of the page. It's good to go. What if you did an ambitious cross-section like Logan Boulevard or something? You went all out, and you've got the section that's twice the size of this. Well, in that case, you might need to make the whole thing smaller or larger. That's easy to do. Just select everything, and just holding down Shift, you can make this. Maybe this has to fit in a report. You can make this thing tiny so it fits in a little panel in your paper. No problem. It's not going to pixelate because there are no pixels. Actually, that's not entirely true. The Photoshop files are pixels, but they're fairly high quality. You can see we have to get in pretty close for them to start pixelating. And of course, our background picture is pixelated. But for the most part, anything you construct in Illustrator is a vector graphic, and it's not going to pixelate. So if you've got something that's too big or too small, make it so it fits on the page nicely and scale it all up. Then finally, just add the key text, sidewalk width, through lanes, bike lanes, and so on. You could add, when you're looking for cars, you may find a cyclist. That would be kind of cool to have on here. When you've got a lot of lanes, you've got some choice on how you're going to show the different use of the lanes here. And when you get some cars in there, that's also going to blunt the picture a little bit. So I'm liking the picture more and more as a sort of design choice, actually. Okay. In the real world, you would want your identity cohesively on every page. Start thinking in terms like that. Moving forward, make sure the page makes sense as something that you can show on its own. Nobody cares about the class or who I am. Just put your identity on there, maybe with a UIC logo, and you're good to go. You know, you can download those UIC logos online, and there's no reason not to do that. They also have the UIC logos in vector format. They are EPS files that they have online, and Illustrator will open that right up. Take a look over this idea of placing raster art, this little sort of memo. It's a good shorthand thing about when you're placing art inside of Illustrator. One of the key things and where people go wrong, now that we're working from home, actually, funny enough, here's one problem that we don't have, is losing assets on the lab computers. Because if I select this Photoshop file that I've placed in here, for example, notice on my context-sensitive menu, I've got some options. One of them is to embed the image. If I embed this image, it becomes part of my Photoshop file. Because I have that option up here, that means they're not embedded. That means every time I open this Illustrator document, Illustrator goes and looks for this, meaning it checks the file path. If I look at my links panel, here is that link, right, the Photoshop document, and Illustrator goes and checks this file path and brings it into this file. So I can't tell you that one way or another is better. I like them linked because in my typical workflow, I might be working on these. Here's a classic example. I'm working on a booklet, and I've got, let's say I've got 30 pages in InDesign, but I've got my cover that I did in Illustrator. I don't want that cover to be part of my InDesign document. I want that cover to be separate because I'm likely to be working on it for quite some time. And after it's reviewed by the client, I'm likely to have revisions on it. So it's much simpler to have it as a separate file, and I can just go ahead and edit it, and every time I open any file that references it, it's going to load the current version of that file. So that's the thinking behind the embed. If you're moving from computer to computer, maybe at home, maybe you're, I don't know, maybe you're working from home, working from work, you can always embed these files, and that makes them part of this document now. See, I don't have the option to embed them anymore. I can take this Illustrator file now and to any computer. I can take it to work, I can take it to a school lab, and I'm never going to worry about this Illustrator file not finding these trees because it's part of this Illustrator file. Now, I didn't do the same thing for my background photo, so that's going to be missing. That's the whole thing behind embed or not embed. That's a choice based on your workflow. Okay, so we'll stop here. Thanks for watching, and good luck with your future Illustrator work. That's the end of Illustrator. Next video is going to be on Photoshop, and we'll talk to you then.